Okay, I'm going to do number 1, and then I'm going to have you do 2, 3, and 4 as tries. I'm going to do number 1 because I think number 1 is pretty awesome, and I'm betting that you might have overlooked its awesomeness. So this is a great example of, here I've got a right triangle and the Pythagorean theorem. So like it says, the early Greeks thought of the theorem as the area of the square of the hypotenuse. So I'm going to make the hypotenuse, and look, I'm going to make my pen a little bit darker here. I'm going to make the hypotenuse this green. Okay, so let me go back here. Let me make it a little bit thicker. And look at that. I'm going to make it this green color. Oh, I don't like that. I like the green, but it needs to be, there we go. Look at that. So they thought of, I might have to move this, and then I'll move it out back over there. Check this out. Let's resize it just a little bit so I have a little bit more room. So I have to make a square on that hypotenuse. A little bit. And a little bit more. There. Does that look like a square? No. This doesn't even look like a right angle. There we go. Oh, there we go. I wish I had a tool. I think I do have a tool to make a square. I'm doing my best here. Okay, so that's supposed to be a square. And I'm gonna color it in. So the area of this green square, kind of looks like a rectangle to me, but who's really looking too closely, right? The area of that green square is equal to the sum of the area of this square plus this pink square. So if I take the pink and the orange squares, if I take that pink and the orange squares and I add them together, it's going to be the area of the green square. So this is what's so cool about it, though. This is what's so cool about it. So this side is C. So C squared, right? The area of that square, area of the green square, okay? The area of that green square is equal to, check this out. That leg I'm going to call A, and the area of that square is A squared. And if I add to it the area of the pink square, well, we'll call that leg B. So if that leg is B, then B times B would be the area of the square. That's B squared. That is so cool. Is that not cool? That is cool. So number 1, that's kind of how the early Greeks thought about Pythagorean theorem, and it's not a bad way for you to think about it either. Now, your task is to do 2, 3, and 4. So press pause, try 2, 3, and 4, and when you come back, you're going to get the answers. Okay, so the answer to number 2, I'm going to make my pen just a little bit thicker. The answer to number 2 is C and D. C and D. Number 3, the square root of 3 quantity squared is the same thing as the square root of 3 times the square root of 3, which is equal to 3. And number 4, 3 times the square root of 11. This is an important one that students overlook, and then when they get to a test or they have to use this skill, they don't know what to do. 3 times the square root of 11 squared is 3 times the square root of 11. I'm not going to put that in parentheses. Times 3 times the square root of 11. Some students will recite that as 3 root 11. It's not 3 root 11. It's 3 times the square root of 11. So when we think of that as the multiplication that it is, we can take 3 times 3, which is where that 9 is coming from. 3 times 3. And then the square root of 11 times the square root of 11 is just 11. And 9 times 11 is 99. So that's the answer to 2, 3, and 4. And those are very, very important skills that you should have down pat when you are working with the Pythagorean theorem and lots of other areas in geometry.